What I'm going to do here is just to illustrate the point. Just to illustrate the point. We're still talking about this alternate format for the derivative. So this is just an example to illustrate what's happening here. Find the slope of the tangent line. All we're asked to find is the slope of the tangent line to this function, x squared plus 2, when x is equal to 3. That's all we're asked, to find the slope. All right? So, one way is to use this format to find the derivative. The slope of the tangent line is find the derivative, evaluate it at the specific point in question, and that's the slope of the tangent line. Alternately, we could use this other form for the derivative, and it will find this for us directly. Each of them has advantages, each of them has disadvantages. What you should be able to do is work with either one so that whenever one is called for, you can use it. If the other is called for, you're equally adept at the use of it. So, part one, we're going to use the original definition. And so, let's see, we want the derivative of x to be the limit. Delta x goes to 0. And let's actually put the value in. F of x plus delta x into x squared plus 2. So this is x plus delta x squared plus 2. So there's the first piece. Minus, whenever you subtract a function, always subtract with parenthesis. All over delta x. And then algebra happens here. So a bunch of algebra ensues. Square this out. This should be part of your comfort zone by now. X squared plus 2x delta x plus delta x squared plus 2 minus x squared minus 2 all over delta x. And then the x squareds fall out, and then the plus 2 minus 2 falls out. We're left with 2x delta x plus delta x. So this is the limit. Delta x goes to 0. I have 2x delta x plus delta x squared over delta x. Factor out delta x and cancel. Factor out the delta x, leaving behind 2x plus delta x over delta x. Cancel, cancel. And now we can, I'm running out of space here, so I'll go ahead and substitute here. Substitute delta x equals 0. So this is 2x plus 0 is equal to 2x. So the derivative function is 2x. So we have f prime of x is 2x. We want the derivative when x equals 3. So we know f prime of 3 is equal to 2 times 3, which is 6. So when we work this out over here, we stinking better get 6 out of that mess. All right, over here, we're going to change our perspective. Remember in our original picture, right, when we have this as x, we change this to be a. So instead of, from this perspective, we don't call this x equals 3. From this perspective, we let a equal 3. So we want to find f prime of 3. So our goal is to find f prime of 3. And as we've seen, if this is correct, we better get 6 out of all this mess because we're finding f prime of 3. Use this notation. This is the limit as, wrote this backwards here, this is x approaches a, x approaches a, x approaches a, and a in this case is, where's my number, 3, all right? I need f of x is x squared plus 2, minus f of a, I need to evaluate the function at 3. Evaluate the function at 3. F of a, you take a into the function. F of a takes a into the function. That's 3 squared plus 2. All over x minus a. This is the limit as x goes to 3. I have x squared plus 2 minus 9 minus 2 all over x minus a was 3. A is 3. The 2's cancel. So we're left now with limit x goes to 3 of x squared minus 9 over x minus 3. X is 3. A is equal to 3. A is equal to 3. Direct substitution gives us 0 divided by 0. But we followed this path before. We should be familiar with this trail. This is factor reduce try again. So this is equal to the limit x goes to 3, x plus 3, x minus 3 over x minus 3, and they cancel. And we're coming down the home stretch. This is the limit as x goes to 3 of simply x plus 3, which is 3 plus 3, which is 6, which is what it's thinking better have been. All right? So the procedure is straightforward either way. Some students say, well, this is a lot easier. Well, it might be easier in this particular problem. It might not be quite so easy in a different particular problem. You should become adept using both this definition or this definition, because you never know when you have some jerk of an instructor on the exam is going to say, use this method. And if you don't use that method, then you don't get a whole lot of credit for your work. So the point here is that, well, the large point is you should become adept at both versions. The smaller, by the way, point is you get the same answer both ways. If you want to practice this, just pick yourself a little function. Doesn't have to be very elaborate. Practice this using some function, find the value, and then practice this using the same using this format with the same function. You should get the same number both ways. So that's the alternate format for the derivative, and you should be familiar with both and able to work with both.